Hi guys, welcome to this video on substitution for linear systems of linear equations. Today we're going to go over how to solve a system of equations using the substitution method. So up here you have this warm up here, make the substitution and distribute. So I'm just going to get you started and then I'll let you finish it on your own. Getting you started here, I see that y is equal to 3x minus 2. So I'm going to take this amount of 3x minus 2 and I'm going to substitute it for y here. When I do so, I get 2x plus 3, and I'm going to use parentheses here just to kind of indicate that I still have some multiplication to do. 3x minus 2 equals 16. So now all the distribution I'm going to leave to you, but just remember that you are going to multiply the 3x and the negative 2 by positive 3. Okay, so today, here's the learning targets. We are learning to solve a system of equations for the solution coordinate using substitution, because it's one of the big three methods and an essential ACT skill. And you'll know you're successful when you can solve an equation that has two equations in standard form or slope-intercept form, and it won't matter at which form it gives you, you'll be able to solve them either which way. So, substitution. The actual verb substitution means to put in place of another, okay? So in algebra, substitution means putting numbers where there are letters. However, when we substitute equations into other equations, we're not always going to just get a number. Instead, sometimes the formulas just get simpler. We lose a variable along the way, which is ultimately the goal. We want one of the variables to be gone, per se. Imagine air quotes around that, because then we can solve the single equation with a single variable for that variable and use it to solve the rest of the system. Now, a good practice to get into is that when you are substituting negative numbers, put parentheses around them so that you get your calculations right. Because remember that negative 2 in parentheses squared is positive 4, and negative 2 squared, when you just plug it in the calculator without parentheses, is negative 4. Now, this is the correct output, and this is the incorrect output for squaring negative 2, just to be aware. So if you take a look at the example down here, especially when you substitute negative numbers 2 and you're subtracting them, one take away negative 2 is positive 2, plus negative 2 squared is positive 4. If you make negative errors when substituting, you might get answers like 5. You might get answers like negative 3 or negative 5 or negative 5. It's entirely possible if you forget to put parentheses around your negative numbers. So, what is the substitution method? So a way to solve a linear system algebraically is the substitution method. This works by taking one of the equations and replacing part of it with the other equation. So here's an example of a substitution happening. I have 2x plus y equals 11 and y equals 3x minus 9. So since I know that y is equal to 3x minus 9, all right, I'm allowed to take this value here and I'm allowed to replace any other copies of y with what's inside this box. So when I do that, it looks like this. 2x plus, well, I don't want to write y anymore. I want to replace it with this. So plus 3x minus 9 equals 11. And now I can combine my like terms. When I do so, 2x and 3x gives me 5x. So 5x minus 9 equals 11. That's an easy enough equation to solve. So before, I had two separate equations and no way to really solve them. But once I use substitution, now I'm allowed to solve this single variable equation for x. using that value of x, I can then go back and find the value of y. And that's the substitution method. So here is a step-by-step process for the substitution method. I will let you take a look at this really quick. So what we're going to do is we're going to manipulate one of the equations to have a solo variable. So you'll know you've done this correct when you see one equation that says y equals, and then there will be an x term over here with something over here. The other version is that you'll see x equals, and you'll have a y variable over here with some extra stuff attached to it as well. That's how you'll know you're ready to go and you're ready to actually make the substitution. So the second step is to make the substitution, to actually replace the variable in one of the equations with the other equation. So when you substitute, though, I recommend that you make the substitution using parentheses. This is going to just make your life easier for when we need to distribute, if necessary, and if you have double negatives in there and so on and so forth. Preserving those double negatives is definitely key because it turns into addition, or if it's addition, subtraction within the parentheses. Definitely got to make sure that we keep those. If we lose that process, or that gets lost in the process, we're going to make mistakes in our calculations. So next, you're going to solve for one of the variables, and we do so with our standard SADMAP, okay? Because distribute's up here, and then we're going to use SADMAP, subtraction, addition, division, multiplication, exponents, parentheses. And then once we get one of the answers, okay, we're going to get like x equals something. We'll get x equals a number. We're going to take that value and we're going to plug it into one of the equations. Doing so will allow us to find the other one, the other missing variable, and then we have the answer to our system. And so every answer that we give to a system needs to be in the form of a coordinate. You remember that from the last section, x and y. So take a look at this example. I have one equation that's in slope-intercept form here. Y is equal to negative 2 or positive 2x plus 4. The second equation is in standard form, 3x plus y equals 9. What's great about this one is that I don't have to do any rearranging. I can already see that this top one here, okay, this top equation has y all by itself. So I can just take the value 2x plus 4, and I can substitute it in place of y in the other equation, since they're equivalent expressions. So I'm going to do that. So I'm going to do 3x plus, and now here's where I'm going to use my parentheses. I'm following my own rules, all right, plus parentheses 2x plus 4 equals 9. Now, there isn't a number outside of the parentheses here, so there's no actual distribution that needs to happen. It's not a minus sign or anything like that. So because that's the case, all right, the parentheses are going to basically drop off. I don't really need to worry about them anymore. So 3x plus 2x combined is 5x when I combine my like terms, plus 4 is equal to 9. So now I have a basic two-step equation. I'm going to go ahead and solve by subtracting 4 from both sides, so minus 4, and I get 5x equals 5. I'm going to divide by 5 on both sides, and when I do, I get x is equal to 1. So now I'm going to take this x equals 1, and I'm going to substitute it into this top equation up here. I could substitute it into this bottom one. It's not going to matter which one I do. However, since this one's already solved for y, it's a lot easier to just put the variable x, or the value that I have for x, into that equation. So we're going to do y is equal to, oops, fix my equal sign, 2, and then still using parentheses to represent substitution, 2 times 1 plus 4. So 2 times 1 plus 4, we can come to the conclusion that is 6. So x is 1, y is 6. So the solution down here is 1, 6. Easy peasy. All right, let's take a look at this one here. Okay, I have another equation. All right, this bottom one's already in slope-intercept form, so I think I'm going to start with this one. Again, we're solving by substitution, so taking this amount, and we're going to replace the y in this equation up here. Okay, seems easy enough, so I'm going to go ahead and make that substitution. So when I do so, you know, the 2x out front stays the same. So 2x minus, and here's where the parentheses are really important. So it's 3, and then the parentheses are going in to make sure I preserve my distributing correctly along with my negative signs. X minus 1 equals negative 1. So if we do the distribution property here, okay, we get 2x. So negative 3 times x is, you know, negative 3x. And negative 3 times negative 1 is positive 3. And that's equal to negative 1. So now I'm going to combine my like terms. 2x take away 3x. That is negative x plus 3 is equal to negative 1. So I'm going to subtract 3 from both sides and get negative x equals negative 4. Okay, but I don't want negative x. I want positive x. So I'm going to flip the signs. And when I do so, I get x equals 4. Okay, so cool. I have one of the variables that I need for my system of equations answer. So I know x equals 4. So what I'm going to do is I'm going to take that value and plug it right back into that bottom equation because I know that y is equal to whatever x is minus 1. So real simply, I'm just going to show my work here because I do value showing work. X is 4, take away 1. So we know that y is equal to 3. So the answer that I was searching for is 4, 3. And that's 2 of them. So that one, no more complex than the first one. Okay, the last one, solve by substitution. And this is one of those cases where I have both equations in standard form. My goal, in order to be able to actually make the substitution, is that I need one to have y equals or x equals. So the first thing I'm going to determine is, should I use the first equation or should I use the second equation to try to manipulate? I look at this problem, and through my analysis, I look at that first equation and I say, hey, you know what? 2 and 6, you know what? These have common factors. I really think that when I divide them, you know, if I factor them or do anything like that, the numbers are just going to be a lot nicer. I know that negative 7, 8, and negative 5, they do not have common factors besides 1. Negative 7 and negative 5 are prime. I can't really divide by anything except 1. So it's actually going to result in a lot of fractions. And since I know how averse you guys are to fractions, we're going to go ahead and use this top equation because it's a lot nicer when it comes to keeping fractional values out. So I am going to try to solve this top equation so that x is all by itself. If I do so, I'm going to subtract 6y from both sides. So if I do that, okay, I subtract 6y from both sides, negative 2x is equal to 6, take away that 6y. Okay. It's almost ready to go. I almost am ready to substitute. However, I need to divide everything by -2. Clear that coefficient out of there. When I do so, I get x is equal to, so 6 divided by -2 is -3. And then I've got -6y divided by -2, so that turns back into positive 3y. All right, I am ready to make the substitution now. So I'm going to take this value of -3 plus 3y, and I'm going to plug it into the x in the second equation. I can't plug it back in to the first equation. Okay, I can't go back and plug it into that top equation. I have to use the other one. So I'm going to go ahead and set it up really quick. So -7 times, and then making sure I preserve all my negative signs, -3 plus 3y. All right, close my parentheses. I still have this additional 8y. I can't forget about that, okay? So no forgetting variables. They can't just disappear or anything like that. Equals -5. Okay, so the next step, according to my step-by-step guide, is to use the distributive property. And just remember, I'm distributing the negative sign too. So -7 times -3 is positive 21. I started, but I stopped. All right, so positive 21. -7 times positive 3y is going to give me negative 21y. And then I still have that additional 8y. And that's equal to -5. So I'm going to combine some like terms here. I've got 21 minus, so negative 21y plus 8y is negative 13y is equal to -5. All right, so now this is a basic two-step equation. I'm going to subtract 21. I'm going to subtract 21 and get negative 13y is equal to negative 26. Okay. Dividing by negative 13 to clear out that coefficient here gives me that y is equal to positive 2. So I have went back and figured out that the y coordinate is going to be positive 2. So I could take this and I could substitute it back into either one of these equations here, or I could be more efficient about it, and I'm going to take this and substitute it into this equation that's already solved for x. The net result will still be the same, and in the end I end up doing a lot less work since I know that x is equal to this expression here. So I'm going to just make that easy substitution. I'm all about doing less work, as long as it's enough work in the first place. 3 times 2. Okay, so I made my substitution. So x is going to be equal to -3 plus 6. Fix my 3 a little bit. And then x is equal to, so -3 plus 6 is positive 3. So that is the x coordinate of my solution. And there we go. So we solved a double standard form equation or system by first converting into slope-intercept form, substituting, and then resubstituting to get our final answer. All right, guys, that's it. Thanks for watching.